All right. Week number 10. I told you guys that it's going to be a little bit tougher this week, and I did not lie. There are a few kids that have finished the assessments already, and I was impressed. It was good to see. Okay. What are we going to do this week? We're going to be talking about solving logarithmic equations and solving exponential equations, and I'm going to wrap it up real quick. If you're going to solve an exponential equation, there's two ways to do it. Okay. The first way, I don't know if I have any, I wish I would have had a blank sheet here. Okay, so there's really two ways to solve an exponential equation. And I'm going to solve this one both ways. This is problem number one. This is off our assessment this week. So I'm going to solve this two different ways. The first way is the way that we already learned. If we could get the bases to be the same. So for example, this one, I could rewrite this as a 3. Oops, I'm going to make that thickness a little bit thinner, or else I'm not going to be able to get all of this on my sheet here. So 9 I can rewrite as 3 squared, and then I still have the 2x minus 5 there is equal to, and then 27 can be written as 3 to the third. So if I can write the bases the same, then the exponents are equal. Okay. So in this problem, I have 2x minus 5 is equal to 3. So if I work this out, I get 4x minus 10 is equal to 3. Bring the 10 over. So 4x equals 13. X equals 13 over 4. So that's one way of doing it. Now, most times, you cannot get the bases to be the same. Okay? And then we have to do a different way. So I'm going to do this problem just like, so we know the answer is 13 over 4, right? What is that as a decimal? Because when I do it the next way, it's going to end up being a decimal. So what's 13 over 4 as a decimal? What is that going to be? 3.25? Is that right? 3.25? Okay. So we get 3.25 doing it this way. Now I'm going to do it another way. I'm going to clear this out. I'm going to write 3.25 down here again because it just cleared it up. Okay, so that's one way of getting it. Okay, so the second way of doing it, if you have an exponential function, you can rewrite it as a logarithmic function. So I'm going to rewrite this as a, and that was the first thing that we did when we started working with this section is we wrote exponents as logarithms. Remember, I gave you something like 4 squared equals 16. So you rewrote it as log base 4 of 16 equals 2. Well, I can do the same thing here. I'm going to rewrite this as log base 9 of 27 is equal to 2x minus 5. Now, when we do it this way, we should always be able to solve this. Now, how do you solve log base 9 of 27? I'm going to show you how to do it on a calculator. How many of you guys have a calculator at your hand right now? I'm going to write this down. Okay. So log base 9 of 27. There's two ways of doing it with your calculator. You can write it as, this is called the change of base formula. Okay, change of base formula, change of base. And the reason, because most calculators, yep, I'm going to show you how to do it on decimals. I'm going to show you how to do it on decimals in just a second. Most calculators have base 10. That's what their base is. It's base 10. So when you use log, it will always be log base 10. Well, this has a base 9. So how am I going to do that? Well, if you write it like this in your calculator, if you rewrite it as log of 27 over the log of 9, you will get the correct answer. And make sure you put this in parentheses. So for those of you that have a calculator, type that in. And I'm going to do it on my calculator. I've got the log of 27 divided by log of 9. Okay, log of 9. And I get 1.5. Okay? This is called the change of base formula. So if you don't have a calculator that you can change the base, then you have to use this formula. Now, I'm going to show you how to do it using decimals. And I'm going to show you how to use log of base. And then decimals is an awesome thing because it does have, you can change the base for that one. So let's go to this problem. I'm going to share application screen. Oh no. Okay. It just started spinning. Okay, so Can you guys see my Desmos calculator? Okay, so I'm going to do the change of base formula on there. I'm just going to do, now where do you find log? You have to go to functions, and you have to go all the way down to, I think, calculus. Okay, and you can see there's a log button here. So I'm going to do log, what was it, 27? See, divided by, okay, so I have to find the division sign, divided by, and then I'm going to do log again, all the way down to find log, and then log of 9, and hit parentheses, and I get 1.5. Yay. Okay. So that gives us 1.5. Now let's do it using the other log button. Okay. So I don't know why anybody would use this one, because it does have, if you go all the way down to calculus again, okay, you can see that it has another log. It has log base A. So if you, oops, I should have went to another, sorry about that, guys. I should go to another thing. So again, I'm going to go down to calculus. I'm going to do the one that has log base A. So now you can tell the calculator what base you want. Well, we wanted base 9, right? Of 27. Guess what? I get the same answer, 1.5. So I don't know why anybody would use the log base change formula when you have Desmos and you can put any log, you can put any base in there that you want. So, you know, if you don't have a calculator that has something where you can change the base, just use Desmos. It's awesome. I mean, you can put any base in there that you want. Now, some calculators do have that capability that you can put any base that you want in there. Okay, so that is how you're going to do this week's assessment when you have to change the formula, okay, or change the base. So let's get back to our files here. This is week number 10, main lesson. All right, so I have to share that with you guys again. All right, so we just did this problem, right? Okay, so we know that to solve this problem, this becomes 1.5, right? We figured that out. We used a calculator. We came up with 1.5 is equal to 2x minus 5. Now, if I add 5 to both sides, I end up with 6.5 is equal to 2x. Divide through by 2, guess what? I get 3.25. So I got the same answer solving the exponent two different ways. First I got the base to be the same, and when the bases are the same, we just set the exponents equal, or I changed to a logarithm, and I get the same answer regardless. So let's try one that you can't get the base to be the same. This problem, there's no way you're going to get the base to be the same. This is problem number 2 on your assessment. So my first thing I would do on a problem like this is I would subtract 7 off both sides. Okay, I'm just going to subtract 7, and I end up with 11 to the 10 to the power of negative 10x is equal to, what is that, 54 minus 7, so that's just going to be 47. Now, there's no way you're going to write 47 and 11 with the same base, right? Not a chance. So if you can't, then your next step is, oh, I'm just going to rewrite it as a logarithm. So I'm going to rewrite this as a log. So this would be log base 11 of 47, oops, 47, is equal to negative 10x. What is this? What is this? Somebody please go to your calculator and tell me what the log base 11 of 47 is. Okay, because I don't know what it is. And my calculator is an old one, so I'd have to do the change of base formula, but I don't want to do that. So what is the log base 11 of 47? Now I can tell you what it's going to be close to. 11 to the first is 1. 11 to the second is 121. So I know it has to be like 1 point, maybe 1.3, 1.4, someplace in there. Okay, somebody tell me what the exact value is. What is the log base 11 of 47? 1.6056. Okay, 1.6056 is equal to negative 10x. Boy, how easy is the problem now? All I have to do is divide through by negative 10. So my answer is negative 0.16056. So solving an exponential function when you cannot get the bases to be the same, just rewrite it as a logarithm and solve. That's all it is. It's super simple. Okay? Any questions on exponential functions? Solving an exponential function. Okay? Now, logarithms, way harder. However, logarithms, you know, we already went through types of logarithms. When there's one log on one side and one log on the other side, all you have to do is cross off the logs, right? And this says it's problem number 3, so I'm assuming this problem is on the assessment this week. So there's one log on both sides, cross them off. I end up with x squared minus 9 is equal to 5x plus 5. Awesome. Well, guess what? This is a quadratic. In order to solve a quadratic, I have to get everything on one side set equal to 0. So I'm going to subtract 5x off. So this gives me x squared minus 5x minus 14 is equal to 0. I'm going to hope like heck that this thing factors. 7 and 2. X minus 7. X. Oh, Mr. Shanklin, you're making us factor things again? Okay, so it factors down to this. So what's my solution? X equals 7 or x equals negative 2. That wasn't too bad. However, that was one of the easier ones. Yes, you should check them because you can't put a negative inside a logarithm. So if you put negative 2 here, so negative 2 squared, well, that gives you 4. But 4 minus 9 is negative 5. There's no such thing as a log of a negative number. So right away, that can't be true, because when I put it back in there, it gives me a solution that doesn't work. Yes, it does. Can't have that negative in there. So my answer would just be 7. Now, would I mark it wrong if somebody gave me this as an answer, x equals 7 or x equals negative 2? I wouldn't mark it wrong. They did all the work correctly. But you just have to remember that you can't. Now, you could have a negative for an answer. Okay. So for example, let's say this was x squared plus 9. Okay. And if you put negative 2 in here, well, negative 2 squared is 4. 4 plus 9 is 13. That's positive. So it's when you put it back in, if it's negative, then there is no solution. But if you plugged it back in and you ended up with a positive number in here for the log to take, that's fine. But usually when you get a negative answer, it usually doesn't work. Okay. All right. So now, the other way to solve a logarithmic equation is to rewrite it as an exponent. What? We just rewrote exponents as logarithms. Yes. If you can't just cross off the logs like we did here, then you can rewrite it as an exponent. Okay, so let's try a problem like that. If I gave you this problem here, you can't cross off a log on both sides. Why not? There's not a log on both sides. So then it's like, oh, I'm going to rewrite this thing as an exponent. Yes, exactly. So if I write this as an exponent, that would be 6 to the negative 1 power is equal to 2x minus 1. Now, it's no longer a logarithmic equation. It's just, can you solve this? I would rewrite 6 to the negative 1 is 1 over 6 is equal to 2x minus 1. If I add 1 to both sides, I end up with 1 and 1 6 equals 2x. Then I divide through by 2. Probably get my calculator out now to get my answer. But that's one of the methods, is if you can't solve the log, just rewrite as an exponent. It's one of those things that I always tell kids, if it's an exponential function, rewrite it as a logarithm. If it's a logarithmic equation, rewrite it as an exponent. But it doesn't always work. I mean, for example, if I gave you this problem here or this problem here, it doesn't matter which one we do. Now, well, it is going to work, but we're going to have to do a little bit of work before then. For example, let's take a look at this problem here. We learned last week that we can rewrite as single logarithms. single logarithms. If you ever have a problem that has more than one logarithm in the problem on the same side, rewrite it as a single log. Now, I would not say x squared plus 4. You got to keep the log in there, right? You can't just say x squared plus x. You've got to keep that log there. So this is going to be log base 12 of x plus 1 equals 1. Now I could rewrite this as log base 12 of x squared plus x equals 1. See, Ari, how you got to keep that log in there. You can't get rid of that. So now that I have it written as a single log, I'm going to rewrite it as an exponent because there's not a log on both sides, so I can't cross it off. So I'm going to rewrite it as an exponent. 12 to the first power is equal to x squared plus x. Yeah, it's a quadratic again. So I'm going to rewrite this as x squared plus x minus 12 is equal to 0. And then I would try to factor this down. This factors down to x plus 4, x minus 3, negative 4, positive 3 on my solutions. I'm thinking negative 4 is not going to work because if I put negative 4 back in here, negative 4 plus 1 is negative 3. You can't have a log of a negative number. Can't work. Boom, gone. So then, but 3, if I put 3 in here, you can find that. You can find that. So yeah, that does work. So 3 is a solution. Now, again, I would not mark that wrong on an assessment if somebody gave me negative 4 and 3. I'm not going to get that. They did all this excellent work. Not going to mark it wrong because they didn't check their answer. I would negative 4 plus 3, good, got it. Be okay with me. But that factoring is, it comes back in a lot of math classes, let me tell you. It's that factoring that will kick some people in the butt. I know it does. I've seen it all before. All right, so let's get back to our practice problems. Okay, I gotta, oops, I'm still in my Algebra 1. So let me get to Algebra 2 so we can take a look at the problems for tonight for the practice. Okay, I think that's it. View dashboard. Okay, copy. Okay, so here's the thing, the link, and then I am going to share my screen here. I'm sorry if somebody's typing to me right now. I'll take a look at the text in just a bit. I just want to make sure I get this all done here. Okay, so let's share that. No, that is not what I wanted to share. Sorry about that. That's not what I wanted to share. So let's go back. Share. Home tab. Algebra 2. Oh, there we go. That's the one I want to share. Okay. So here's the problem that. Okay, so I'm going to go back, make sure I didn't miss anything. We were just talking about breaking nuns. Okay. All right. So let's take a look at the first problem. Can you get a common base? That's the first thing I do is I look at it and it's like, can I get a common base to these problems? Now that you understand the second method how to solve, you don't even really have to worry about if you can get a common base or not. I don't even use that method. I just go back to it and it's like, oh, I've got an exponential function. All right, so I've got 3 to the x plus 6 is equal to 8. I'm going to rewrite this as a logarithm. So I've got log base 3 of 8 is equal to x plus 6. All right, so somebody with Desmos, please tell me what the log base 3 of 8 is equal to, because I know it's going to be, so 3 to the first is 3, 3 to the second is 9. So it's going to be like 1.8 or 1.9 because it's really, it's very close to 3 to the second. So I know it's got to be pretty close to 2. 1.89. Okay, so now that we know that this 1.89, I don't remember, 1.8927, okay, I would keep all of that in there, is equal to x plus 6. Subtract 6 from both sides, x equals, Well, it's going to be negative something, right? Looks like negative 4.11. And that is how I do exponential functions now. I don't even look to see if the bases are the same. Okay, but if you want to, you can. Mode wouldn't make any difference with logs. The mode only deals with if you're in radian mode or degree mode, so that wouldn't make any difference on the calculator. But if you're having trouble with your calculator, just use Desmos. And Desmos is awesome because you can change the base to anything you want. All right, problem number 2. It says solve the exponential equation. Oh no. It says e to the x plus 2 is equal to 5. I'm going to rewrite this as a logarithm. So that's log base e of 5 is equal to x plus 2. What is another way of writing log base e? Does anybody know? What is another way of writing log base e? Log base 10? No. Natural log. Ansgar, I think you're right, but natural log should be ln. Okay, so you could write it this way. You could rewrite this as ln of 5 is equal to x plus 2. Why is it nice to write it this way? Because most calculators have a natural log button. Most calculators do. Now, could you leave it this way and put it into Desmos with base e? You sure can. But as soon as you get log base e, that stands for natural log. So my calculator has a natural log button. So so natural log of 5 is equal to, I come up with 1.6094 is equal to x plus 2. So now I'm going to subtract 2 from both sides. So minus 2, I end up with negative 0.39056. So I'm going to go with letter C. So that anytime you get log base e, I would keep it to 4 decimals. Yes, I would. Now you can see in the answer key, they only took it out to 2 places, but I usually keep it to 4 because you get a lot better of an answer when you do that. Okay, but anytime you have log base e, write it as natural log. That's it. All right. Problem number 3. All right. Problem number 3, I have log base 5 of x minus 1 is equal to 3. Uh-oh, it's a log problem. There's not a log on both sides. So what should I do? Write it as an exponent. It's exactly right. It's exactly what I would do. If I have an exponent, I rewrite it as a log. If I have a log, I rewrite it as an exponent. So this is log base 5 of x minus 1 is equal to 3. I'm going to write this as an exponent. 5 to the third is equal to x minus 1. What is 5 to the third? Isn't that 125? Add 1. Boom, I get 126. Not. Mr. Shanklin, you were saying that this is going to be such a hard week this week. I mean, I will tell you, students that don't come to the main lesson or watch it, they are not going to get these answers. I can guarantee you that. And you guys are the dedicated students. You come to the classes, you ask questions. It's the other ones that don't. They're going to struggle with this stuff. They're going to struggle mightily because you're not going to know how to do it. All right. All right. Let's go to problem number 4. I'm going to let you. Yeah, the answer is 126. Sorry about that. My writing is not the greatest there. Okay. I want to get to a problem where I want you guys to do it so I can go and take attendance. Okay. I'm going to let you guys work on this problem. I'm going to write it out for you guys so you can see it. It's a little small sometimes on the screen. So this is log base 2 of x plus log base 2 of x minus 3 is equal to 2. Okay. You guys work on this. I am going to take attendance. Okay. So you guys, now the first step, I would rewrite it as a single log. There's no question about it. Okay. That's all I'm going to say. I'm going to take attendance. Okay. Whew, let's see here. I did not look at, okay, then set equal to 1. Rewrite it as exponent. Okay, so if I was going to do this problem, first thing I'm going to do is I'm going to rewrite this problem as a single log. I have two logs on one side, so I'm going to rewrite this as log base 2 of x minus 3 is equal to 2. Okay, so far so good? We okay with that? Now remember, when we rewrite it as a logarithm, the log is still there. Now, Samantha, I'm looking at that. Looks good. Yeah, looks pretty good. So now, if I rewrite this thing, I'm going to rewrite it as an exponent. So that's 2 to the second is equal to, I'm just going to rewrite this as x squared minus 3x. So that's a 4 there. X squared minus 3x. I'm going to rewrite it as because I want to solve this problem. It's a quadratic, so I got to get it set equal to 0. X squared minus 3x minus 4. I'm going to factor. What two numbers multiply to give me negative 4, but add up to negative 3? X minus 4, x plus 1. So what are my solutions? Positive 4, negative 1. Now, if I put negative 1 back in there, negative 1 is not a solution, is it? Because if you put negative 1 back in to log base 2 of negative 1, how are you ever, log base 2 of negative 1? There's no such thing. There's no way you can take, so that's really asking you 2 to what power is equal to negative 1? There's no such thing. There is no number that will ever give you, you can't take something, you can't take a positive number to an exponent and ever get a negative number. It doesn't work. So the answer should just be 4. No, it does not matter what order they're in. But in this problem, it does matter if you found the error, right? Because if you left negative 1, you'd say the answer is D, right? But the answer really should be C, because negative 1 does not work. It does not work. So in this one, you've got to say that the answer is C. No, if it's a positive fraction, you cannot, because think about it. If you think about negative exponent or trying to get a negative number, I don't care what fraction you take. Let's say you have 1/2. Then take it to the second power, you get 1/4. Take it to the third power, you get 1/8. It doesn't matter what power you take it to, it will never make this a negative number. Some kids will say, well, Mr. Shango, take it to a negative exponent. Well, if I take it to a negative exponent, that gives me 4, doesn't it? Because 1/2 to the negative second power is the same thing as 2 to the second power. Never, ever, ever get a negative number from that. Okay? So if you ever have a positive to an exponent, never can be a negative number. Can't. I mean, unless you guys know some math that I don't know. I just don't know how to get to a negative number there. So, yeah, and if you take it to a fractional exponent, still not going to make it negative. Okay? Oh, okay. All right. Problem number 5. Let's take a look at number 5 now. So our answer should be letter C, right? Go with letter C because negative 1 did not work there. Okay. All right. So number 5. It says solve the logarithmic equation. All right. So I've got log base 4 of x plus 2 minus, it looks like a minus sign. I think it's a minus sign. Log base 4 of x equals 2. All right. So I'm going to rewrite this as a single log. Log base 4 of x plus 2 over 4 is equal to 2. Oh, I'm sorry. That's x. Sorry about that. Should be an x. X plus 2 over x is equal to 2. I'm going to rewrite this as an exponent. So 4 to the second is equal to x plus 2 over x. 4 to the second is 16. So 16 is equal to x plus 2 over x. Now, whenever I get to this point, a lot of kids are like, well, how am I supposed to solve this? Proportion. Rewrite it as a proportion. So if If I cross multiply, 16 times x gives me 16x. X plus 2 times 1 is x plus 2. So I just cross multiply. Subtract 1x from both sides. 15x equals 2. X equals 2/15. Awesome problem. Now, a lot of students, it's not the logs that they mess up with. They're good with the logs. It's solving. Okay? Once we got to this point right here, where it was 4 squared equals x plus 2 over x, guess what? That is where most kids have their problems. Okay? That's where kids are going to struggle. They're going to struggle with trying to, solve the equation. But, you do enough of them, it's not that bad. You could multiply both sides by x. That would have worked to get rid of that x in the denominator. I just cross-multiplied because it's solving as a proportion. You can cross-multiply. That's how I did it. Multiplying both sides by x would have gotten rid of the x in the denominator also. Both ways work. I mean, my method is not always the easiest. But yeah, you could do it either way. You could have multiplied both sides by x. That would have gotten rid of the x in the denominator. Perfectly fine. That does work. All right, number 6. It says solve the logarithmic equation. Oh boy. Now I'm going to write this down. I'm going to use it a little bit. So I've got log, no base, and so it's really base 10, plus log, is that x minus 1, I think? My eyes are not the best, is equal to log of 30. Okay? So in this problem, it's like, oh, anytime I see more than one log on one side of the equation, I usually would go right away and rewrite that as a single log. That would be my first step. Okay? But then you're going to notice that you're going to have one log on the left-hand side, one log on the right-hand side. And that's like, oh, that makes it nice because then I can cross off the logs. If you have one on one side and one on the other, you can cross them off. Okay, so first step, combine the logs. It's a plus sign here. So this is going to be x, so log of x minus 1 is equal to log of 30. Guess what? I have one log on one side, one log on the other side. I can cross them off. So I'm left with x. I'm just going to multiply that through. X squared minus 1x equals 30. Guess what? Again, quadratic. X squared minus 1x minus 30 is equal to 0. Try to factor. Well, what two numbers multiply to give me 5 but add up to -1? Or I'm sorry, what two numbers multiply to -30 that add up to -1? Well, that's going to be -6 and 5. So what are my solutions? X equals 6 or x equals -5. I'm going to say that this probably is not going to be a solution because if I put it in here, it does not work. Cross it off. So it looks like 6 is the only solution that would work there. Okay. Hopefully the quadratics are coming back to you guys. Hopefully. Keep my fingers crossed that they're coming back. All right. Problem number 7. Let's take a look at it. Number 7, it says solve the logarithmic equation. So I'm gonna let you guys work on this one for a little bit. Okay, so I'm gonna just write it out. Log x plus 23 minus log of 3 is equal to log 10x plus 3. Okay, so I'm gonna let you guys work a little bit. I see I'm getting a lot of emails, so there must be something wrong in my other classes. So you guys work a little bit, and then I'll come back and do that problem. Okay. Okay, let's take a look at this problem. 32 over 29. Wow, kind of a crazy answer there, right? I would say you probably did something wrong. Why do I say that? Because your answer's not up in the game. That's only that's I look at the multiple choice and it's like, okay, probably something's wrong there. I haven't worked it out yet, so I'm not 100% sure. All right, so if I did this problem, the first thing I would do is I'd look at this and I'd say, okay, I'm going to put this together. It's a minus sign. So remember, it's log of x plus 23 over 3, okay, is equal to log 10x plus 3. Okay, now I have one log on both sides. Awesome. Cross them off. So I'm left with x plus 23 over 3 is equal to 10x plus 3 over 1. Why did I put 1 under there? Because I know what I'm going to do. I'm going to cross multiply. So if I multiply 3 times 10x plus 3, I get 30x plus 9 is equal to, and if I cross multiply on this diagonal, I just end up with x plus 23. Subtract 1x from both sides. I get 29x, and then I'm going to add 9. Or I'm sorry, I'm going to subtract 9 from this side. 29x equals, what is that, 14? So I'm going to divide through by 29. I get 14 over 29. That is the hardest problem that I could give you. Wait. All right, so that's where I was starting. Okay. Why did I subtract 1x? Because I want to get the x's. Anytime I have variables on both sides of an equation, I want to get the variables on the same side of the equation. Now, could have you brought the negative 30x over to the right-hand side? Absolutely. But I like to keep my variables positive, so I subtracted 1x from both sides. And what does that do? It gets rid of the x on the right-hand side and subtracts 1x off on the left-hand side. Okay, so that's why I took the x out of there. Anytime I have variables on both sides, I want to get it on one side. You don't want variables on both sides of the equation. It just doesn't help you to solve the problem. That's the key. That's why you want to get them both on the same side. Yes, I am isolating the x. Correct. And remember, anytime you have a variable that doesn't have a number in front of it, it's 1. So that's why I subtracted 1 off. Okay. All right, now, Tyson, I just looked at your email. Do you understand where your error was or my error? Did I do something wrong on that one? Do you understand how to use the calculator, the Desmos calculator? Okay, so you got it figured out? Okay, all right. Awesome. Yeah, because I mean, I could have made a mistake during that presentation. I don't know. I mean, when I do those, sometimes I don't go back and check myself. All right, so let's take a look at problem number 8. Uh-oh, exponents. Now, this one's a little bit tougher than, could you rewrite this as a logarithm? Could, but I think it's going to be harder to do that. Okay. Whoa. No solutions? Oh, as an answer? Now, in this problem, I look at this and I've got exponents on both sides. And it's like, oh, okay. Usually if that happens, I can rewrite it as a same base. I'm going to rewrite 4 as 2 to the second power, 4x minus 1. 32, I'm going to write as 2 to the 5th power, right? Is 32 2 to the 5th? I got to make sure 2 to the 5th power is 32. Yep. So I'm going to rewrite that as 2 to the 5, 2x minus 1. So now I rewrote them common bases. Bases are the same, exponents are equal. So this whole problem just turns out to be this, 4x, 4x minus 1 equals 5, 2x minus 1. That's all it is. I mean, I rewrote it with a common base. So now this is the equation I have to be able to solve. Okay, so I'm going to multiply through here. So 8x minus 2 is equal to, I'm going to multiply through here. So that gives me 10x minus 5. Again, I have variables on both sides, so I'm going to subtract 8x from both sides. Why? Because I want to keep this to be positive. So this is going to cross off. I'm going to be left with negative 2 is equal to 2x minus 5. Add 5 to both sides. I'm just solving the equation. So I'm left with, sorry, I'm running out of room here. A 3 is equal to 2x. Divide through by 2. I end up with x equals 3 halves. Letter C. So the hard part, for some kids is going to be just solving that equation. The algebra 2 is gone as soon as I got common bases, and then I just rewrote it as 4x minus 1 equals 5 times 2x minus 1. Then it's just algebra solving. Now, could have you rewritten it as a logarithm? You thought it was going to be a quadratic? You could have, remember we said, now, I haven't tried this problem doing it the other way. So let's say, okay, so I might kick myself after I do it this way. So remember, I told you guys, if you have an exponent, you can just rewrite it as a log, right? So I could rewrite this as the log base 4 of 32 to 2x minus 1 is equal to 4x minus 1, right? You can rewrite it as a log. Now remember, you can put this in the front. So I could rewrite this as 2x minus 1, and then log base 4 of 32 is equal to 4x minus 1. What is the log base 4 of 32? What is that? Isn't 4 to the second power, 4 to the third? So you'd have to be able to figure that out. Not a nice number. It's got to be halfway nice. I mean, it's going to be like 1 point or 2 point something. So can somebody do that on decimals? What does that turn out to be? It's going to be 2.5. Okay, so 2.5. So now this becomes 2.5 here. Okay, so then I end up with 2.5 times 2x minus 1 is equal to 4x minus 1. You'll get the exact same answer. You're going to get 3 halves when you solve this. It's a little bit harder because it's got a decimal in there, but you're going to get the same answer. I just noticed that the bases were the same. It's like, oh, if the bases are the same, I can just rewrite it with the base the same. But if you didn't notice that, you could rewrite it out as a logarithm, just a little bit trickier to solve that way. But you're going to get the same answer regardless. You're going to end up with 3 halves. All right. So, can you get a common base here? And let's say you couldn't. Probably. You could. You can. Because I could rewrite both of these with a base of 2 again. Because 4 isn't 4 the same thing as 2 squared? And 0.5 is really 1/2, right? So couldn't I rewrite 1/2 as 2 to the negative 1? Isn't that the same thing? So in this problem, I can rewrite them with the common bases. And if I do that, I end up with 2 to the second, 2x minus 5, is equal to 2 to the negative 1, and then 2 minus 2x. Bases are the same, exponents are equal. So my whole problem turns out to be this. What was that, 2 minus 2x? So that would be my whole problem. And then now it just comes down to, can you solve that? And that is one of the things that, some kids, the answer is going to be no. And some kids are going to go, oh yeah, that's super easy, Mr. Franklin, I can do that. What is my answer if I do that? Did anybody get an answer? You can't solve? That's because you haven't even tried yet. There's a difference between you can't and you don't want to. Right, Samantha? I know you can. You just don't want to this morning. All right. So let's go to it and see if we can solve it. I'm just reading through here. There's some. Okay, I'll open that. All right. So if I'm going to solve this problem, I'm going to multiply through by 2. So that's going to give me 4x minus 10 is equal to -2 plus 2x. I want to get the variables on the same side, so I'm going to subtract 2x from both sides. So I end up with 2x minus 10 is equal to -2. I'm going to add 10 to both sides. 2x equals 8. X equals 4. Yay. I think I'm correct. And why do I think I'm correct? Is because the answer is over in the multiple choice part. So saying, okay, must be right. I always think that if the answer is in the multiple choice, it's got to be right. All right. Next question. Next problem. It says, what is the sum of, oh, I don't like these problems. I do not. It says, what is the sum of the solutions of the equation x base 2 minus 3x plus, oh, this is going to be a quadratic too. Oh, yeah. Okay. So if I'm going to do this problem, first thing I'm going to do is I'm going to rewrite it as a single logarithm. So I'm going to rewrite it as log base 2 of 2 minus 3x, oh boy, times 4x plus 6. See where my problem's going to be already? Oof. So now it's a logarithm. So I'm going to rewrite it as an exponent. So this is going to be 2 to the second power, which is 4, is equal to 2 minus 3x times 4x plus 6. And I'm telling you, I didn't put any problems like this on your assessment. So I have to FOIL this. You have to FOIL this thing. So this is going to end up being, what, 8x plus 12 minus 12x squared minus 18x. All I did is I FOILed this out, multiply these, and then I'm going to simplify. So this becomes, what is that? Negative 12x squared. 8x plus negative 8x, that gives me negative 10x plus 12. And then I'm going to move everything over to this side. Why am I going to do that? Because I want this to be positive. So I end up with 12x squared plus 10x. And then if I bring this over, that's going to be negative 8. Oh boy. Does everybody remember how to factor using the cheater method? Now, I think I probably would factor out the greatest common factor first, which is 2. So I can factor out a 2 here. So that gives me 6x squared plus 5x minus 4. But now I have to use the cheater method to factor this. So remember, we multiply the outer two terms together. Well, first thing we do is we cheat with the number inside here. So that's going to be a 6x here, 6x. Here, we multiply the outer terms. That gives me negative 24. What two numbers multiply to negative 24? That add up to 5. 8 and 3. 8, negative 3. But remember, we cheated with a 6, so we have to divide a 6 out. But you can't divide a 6 out evenly, so we break the 6 down to 3 and 2. So I'm going to divide by 2 here and a 3 here. And if you don't get this, that's fine. It's not going to be on the test this week. So that's 3x plus 4 and 2x minus 1. So 1/2 and negative 4/3 are my solutions. Now, negative 4/3 in this problem probably would work, because if I put negative 4/3 in here, that's going to give me a positive here. And negative 4/3, that's going to be a positive here. So they're both going to work. So negative 4/3 and 1/2 are my solutions, but it said, what is the sum of the solutions? This is a really bad problem. I should have taken this one off. So that's going to be negative 8/6 plus 3/6. So that's negative 5/6. So go with A. Don't go with A. Don't even. That one should not have been on the practice. That one. Yeah, blindly accept A for the answer for that one, because that reviewed a lot of stuff in algebra. Yeah, should have taken that one off. Don't even think about that problem. There's nothing that hard on the assessment. Trust me, it is. Okay, whoop, that was the last problem. There is nothing that hard on the assessment this week. I did not put anything like that on there. So you'll find that most of them are fairly easy to solve. You're going to get some fractions for answers. There's no question about that, but that doesn't mean that they're hard to solve. Okay. Whew, that was it. That took us almost the whole time today. Remember, if you have any questions and you need some help for Wednesday help session, 1 to 2. Yeah, I know. I should have crossed that one off. All right, you guys have a great week. Hopefully we'll get some warmer weather by the end of the week. And some sun. We need to get some sun out there. Sun makes everything better. Bye.